Before we can get into how to build graphics pages, it's important to understand how data flows from the hardware up through the server software and finally arrives at the client. The basic hardware architecture should be familiar to you by now. Data is generated by the equipment, whatever that may be. The server, which may consist of multiple physical machines, connects to that equipment and reads the data using its supported communication protocols. The server then compiles the data into alarms, trends the data for later access, and performs Psycode operations to analyze the data. Let's look a bit deeper at this process. So far, we've been configuring this Cytect data acquisition engine. You've developed device types and profiles using Profile Editor, then built out a database in Studio. I'm simplifying this process, of course. There are other tools and steps as well, but the idea is to configure our data acquisition and processing. Once this is done, the engine makes the data available using the CT-API, the Cytect Application Programming Interface. This allows client applications to access real-time data, alarms, and trends, as well as make Psycode function calls on the server. There is another component to this abstraction layer called the Schneider Electric Core Service Host, and we'll discuss that from time to time. This service manages external connections to the CT-API and makes data available in a more standardized format. In our current discussion, the Core Service Host is providing data to this graphics rendering engine. You will build graphics files using Graphics Editor and save them in TGML format, TAC Vista Graphics Markup Language. The rendering engine then takes these files, compiles them to HTML5 format, connects them to data from the CT-API, and makes the pages available to the web server. These components originated in EcoStruxure Building Operation, which is why you will see references to that software package occasionally. Also, note that this diagram is not complete. There are also connections between Graphics Editor and Studio, which enable you to easily bind graphic points to tags and equipment in the system. In addition to the graphics engine, other applications may connect to the CT-API layer to access data. Basic Reports and Live View connect in the same manner, and the alarm rendering engine displays alarms in a fashion consistent with the rest of EcoStruxure Power. This component also enables alarms to be grouped into incidents and analyzed in a similar manner. Finally, the server groups these components, along with advanced reports and dashboards, if integrated, into a single coherent website to be accessed by client machines. The site is fully HTML5 compatible, so these clients can be any machine running a modern web browser, be it a dedicated workstation running a large screen monitor, an engineering laptop, or a tablet PC. This is the end goal of configuring this software: gather data from the hardware, process it as necessary, and present the data to the end user. In the upcoming videos, you will learn how to build and integrate these graphics pages. Until then, thank you.